For centuries, the Earth's age has remained a mystery. The creation of the Earth has perplexed thinkers. People have been looking for clues to help solve the puzzle. In 1650, Archbishop James Ussher made a careful study of the Bible and other historical sources. He concluded that Earth had been created at midday on 23rd October 4004 BC. Other scientists such as Edmund Halley tried to solve the mystery in a non-religious approach. He believed that we can calculate the age of the Earth by dividing the amount of salt added to each year. This theory was dismissed because it was impossible to measure the amount of salt in the oceans. The first attempt to measure the age of the Earth that is remotely scientific was made by Georges-Louis Leclerc, Comte de Buffon. It was known that the Earth radiated huge amounts of heat. He simulated this phenomena by heating spheres until they glowed white hot, and then by estimating the rate of heat dissipation, he guessed that the age of the Earth was between 75 and 168,000 years. All of these unanswered questions gave rise to the science of geology. Geology is the science and study of the solid Earth and the processes by which it is shaped and changed. By the 18th century, people were already starting to come up with theories trying to explain what had changed the face of the Earth. While Neptunists believed that everything on Earth was changed with the rise of sea levels, Plutonists thought that volcanoes and earthquakes and other active agents continually changed the face of the planet. James Hutton was a scientist who was interested in nearly everything, from mineralogy to metaphysics. But his real passion was geology. While Hutton was still puzzling over the Neptunist and Plutonist controversy, he had a series of exceptional insights. He observed that soil was created by the erosion of rocks. Streams and rivers carried away the soil and deposited it elsewhere. He concluded that Earth would eventually be worn quite smooth. The presence of hills around him contradicted his theory. Clearly, there was some form of change or an uplift that created new hills and mountains to keep the cycle going. First of all, despite Neptune's claims that fossils got on mountains because Earth was previously covered with water, Hutton suggested that fossils had risen along with the mountains themselves. His second suggestion was that heat within the Earth created new rocks and continents and thrust up mountains chains. These suggestions needed a huge amount of time and weren't falsifiable back then. Lyell was born in the year that Hutton died, only 70 miles away in the village of Kinnordy. Lyell gained an interest in natural history, but he fell under the spell of William Buckland. That was when he began his lifelong devotion to geology. He produced the Principles of Geology, which elaborated on Hutton's first thoughts. Just like the debate between Neptunists and Plutonists, a new geological controversy arose between catastrophists and uniformitarianists during the time of Lyell. Catastrophism is the idea that the Earth had been shaped by sudden violent natural disasters, while uniformitarianism assumes that the same natural laws and processes that operate in the universe nowadays have always operated in the past, shaping the surface of the Earth.
Why, I'm James Hudson, my child, the discoverer of uniformitarianism. The geologic processes happen slowly over millions of years and are still occurring today. Hudson, the geologic changes occur suddenly, from severe earthquakes or floods, so the theory catastrophism is therefore correct. Charles, come down here.
Uniformitarianism is right, Tim. It's in your head that uniformitarianism is the true reason the Earth looks like it does today. It wasn't caused by major crises.
Fine, jeez.
Back in the day, geologists tried to classify rocks into 4 categories: primary, secondary, tertiary, quaternary. However, this classification was discarded. Nowadays, geological time is divided into Precambrian, known as before the Cambrian period, Paleozoic, known as Old Life, Mesozoic, known as Middle Life, and Cenozoic, known as Recent Life. These categories were divided into subgroups called systems. Other scientists try to estimate the age of certain regions of the Earth. Charles Darwin announced that the geological processes which created the Weald, an area of southern England stretching across Kent, Surrey, and Sussex, had taken 306,662,400 years to complete. Kelvin was one of the most extraordinary figures of the 19th century. He suggested the method that led directly to the invention of refrigeration. He devised a scale of absolute temperature that still bears his name. He invented the boosting devices that allowed telegrams to be sent across oceans. He had really only one flaw, that was an inability to calculate the correct age of the Earth. He never came anywhere of getting it right. In 1862, he suggested the Earth was 98 million years old, with an error range of 20 million years to 400 million years. Rutherford was a British chemist and physicist who became known as the father of nuclear physics. He came up with a new method to measure the age of our planet.
Rutherford had removed a central plank of Kelvin's argument. Not all the heat inside the Earth was left over from its formation. Instead, heat was continuously being generated within the planet by radioactive decay.
And he suggested that if you had a rock which has a certain amount of uranium in it, the uranium would in the course of time decay to the element lead by radioactive decay, and one could measure the rate of that process.
Nowadays, scientists have used Rutherford's discoveries of radioactive dating to evaluate the age of the Earth. They concluded that it is at least 4.5 billion years old.